All right, so here we'll solve some old exams. Old exams here. Question number 1. It says if x is between 0 to 2 pi, you want to find the sum of solution. So this is what we have. Cosine 2x is equals to sine x. Simply, this you can write as what? We can write everything in terms of cosine, in terms of sine, right? We know that this is nothing but 1 minus 2 sine squared, right? X, and this is the same thing as sine x. We can transfer everything to the other side, so you have 2 sine squared x plus what? Sine x, then minus 1. This will be equals to 0. And then we can make a substitution of u is equals to sine x, so that we can have 2u squared plus u minus 1, that's equals to 0, right? And now this is going to be minus 2 and 1. So what can we do? We can use minus 2 or minus 1 plus 2, right? So we can use minus 1 plus 2 divided by 2. So this we can say this is 2u minus 1, and then u plus 1 equals to 0. So this is 2u here. So it means that 2u it's equals to 1, or u it's equals to minus 1. Now this is u, it's equals to half, or u is equals to minus 1. But what is u? Sine x. So sine x is half, or sine x is minus 1, right? Let's start from here. Sine x is minus 1. What does that mean? It means that x has to be what? Think 270, right? And here we'll have either in the first or in the second, but our reference x, which we can call x star, is going to be 30 degree, which is pi over what? Pi over 6, right? And then, so if we are in the first quadrant, so that x is still going to be pi over 6, and we can add 2k pi. And if we happen to be in the second quadrant, that x is going to be pi minus pi over 6, which will be 5 over 6 plus 2k pi. So these are the solutions. All right, so now let's see if k is equals to 0, what do we get? From here, we'll have pi over 6. And from here also, we will have 5 pi over 6. And from here, we'll have 3 pi over 2, right? So can k be equals to 1? If k is equals to 1, this will be more. So we cannot have k equals to 1. So this is just all the solution set. And now what is the sum of this? The sum is pi over 6 plus 5 pi over 6, which is already pi. And plus what? 3 pi over 2, right? So this and this is just pi. So you have pi plus, or we can make everything the same. This we can write as pi plus 5 pi plus what? If we multiply this by 3, this is going to be 9 pi everything over 6. Right. So what is this? This is going to be 15 over 6 pi. When you divide by 3, it's going to be what? 5 pi over 2. So that is the answer. The answer is A, 5 pi over 2. So let's check for the second one. This is B. Now for B, we have this one. We're going to treat it the same way. We should just write this is 2 sine 2x plus pi over 6 is equals to 1. Remember here you have minus 1 equals to 0. There is a 0 here, so transfer it. It means that sine 2x plus pi over 6 is just going to be what? Half, right? It's going to be half. Then just treat this. This is sine, could be positive in the first or in the second quadrant. So if it's in the first quadrant, what is our reference? Our reference is going to be pi over what? Pi over 6 also. So it means that if we are in the first quadrant, now all of this should be seen as your theta, right? So you just say 2x plus pi over 6 also must be what? Must be pi over 6. And remember here, you can add what? 2k pi, right? So from here now you solve for x. This will mean that 2x, what is 2x? 2x is going to be, just subtract pi from both sides. So 2x is just going to be 2k pi. And that means that x is what? Divide both sides by 2. X is just k pi. Now, if we are in the second quadrant, 2x plus pi over 6, it will be what? It will be, we need to add, since we are in the second quadrant, right? We need to remove pi over 6 from pi, right? So you will have 5 pi over 6 plus also 2k pi. And this will translate to what? It means that 2x is going to be, you take this here, so you will subtract pi over 6 from 5 pi over 6. So which will give you 4 pi over 6 plus what? 2k pi, right? And now you can divide both sides by 2. So this means that x is what? That's multiplying both sides by half. So this is going to be 2 pi over 6 plus what? Plus k pi. And now this is actually saying that x is pi over 3 plus k pi. Okay. So these are the two answers in a box in the general terms. So now let's be specific. When I say specific, I mean we look at the restriction, which is 0 and 2 pi. So we start with k is equals to 0. So if you take k to be 0, what do we mean here? We'll get x is equals to 0. So we'll have x will be 0. From here, we'll have pi over 3. Now, let's say k is 1. If k is 1, from here, we'll get x is equals to pi. That's from here. Then from here, we'll get pi plus, so this will be 4 pi over 3. I think this will go. Right. Then I think that's it. We cannot say k to be 2. If k is 2, then it will exceed our domain. So, and you can see all of these answers are good. So this is our solution set. We have only 4, 0, pi over 3, pi, and 4 pi over 3. So now let's see number 3. Number 3 is asking for what? It says the number of solutions of the equation. So what is the number? This one has to do with multiple angle. This we can write as what? Since we have cosine here, so let's think of this one as cosine. And this we can write as 3 plus, this is cosine, which we can write as 2 cosine squared theta minus 1. And this is what? This is 5 cosine theta, right? Now we can rearrange things to be 2 cosine squared theta minus 5 cosine theta plus 2 equals to 0. Yep. Now we can let u to be, okay, so this is what we did here. Let me just mark it here. It's just to use an identity, right? And these are the same. All right, so u is equals to cosine theta. So you have 2u squared minus what? 5u plus a 2 is equals to 0. Now we can factorize this. This is going to be 4 and minus 5, right? And that means you need two factors that you can multiply to give us 4. And you can add to give us minus 5. So we can go with minus 4 minus 1. And if we divide it by the coefficient of u squared, we will have this. So this we can write as 2u minus 1, right? And simply, this is going to be u minus 2. I think this will do the job. Okay, so this means that 2u, that's equals to 1, or u, it's equals to 2. So, but what is u? U is cosine, so it means that cosine theta is going to be half, or cosine theta is equals to 2. This definitely should be a reject. Now, since we can see, we know that 2 is not in the range of cosine, which is from -1 to 1. So we have only one aspect to deal with. To consider, we need to consider this one only. And what is this? This could be either in the first or in the fourth. So we have that if you are in the first, the reference is going to be what? Pi over 3, right? Which is 60. So it means if you're in the first quadrant, our theta is still going to be pi over 3 plus 2k pi. If we are now in the fourth quadrant, because cosine is positive, the theta is going to be what? It's going to be 2 pi minus pi over 3, right? And this is going to be 5 pi. So because we have 2 pi minus pi over 3, right? So it's 5 pi over 3. And now we can add 2k pi as well. So this is what we can get from this. but we know what is k, right? So k is just an integer. So, but also we have a range for the values of x. So we need to look at what are the possible values of k, starting from k is equals to 0. Okay, so if we start with k is equals to 0, for k is equals to 0, we start, it means we will have theta to be what, pi over 3, and what, 5 pi over 3. Okay, but we need up from 0 to 4 pi, so it's okay. So we can take k to be 1 as well. Let's see, when k is 1, what do we have? If k to be 1, we will have theta to, so here will be 2 pi, so we'll have 2 pi. So we'll have 2 pi plus what? Plus pi over 3, right? So this will be about 7 pi over 3, because we can multiply this by 3, which makes it 6. So this is about 7 pi over 3, which is still okay, because we have up to 4 pi. Now, here, what are we going to get? If you add k is equals to 1, this is 2 pi. So we'll have 2 pi plus 5 pi over 3. So we'll have 5 pi over 3. Right. And this is going to be around 11 pi over 3, right? Okay. Now, we can try also when k is 2. If k is 2, is it still going to happen? This will be 4 pi. This will be 4. Okay. And we don't want to exceed what? We cannot exceed k is equals to what? We cannot exceed k is equals to 2. So let's see. So here we have only 4. All right, so I think here we have only 4 solutions, not 6. So the solution sets, this is going to be pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. So we have exactly 4 solutions, because we're interested in the number of solutions. All right, so let's take, we have 2 more questions to go. Question number 4. So question number 4, it looks, and this now we have to look at the interval is from minus pi to pi. So, but we can look at this and try to simplify. You have so many terms, this like 4 terms. But if you look this, we can write this as what? We can write this as 2 cosine 3x sine 2x minus 2 cosine 2x sine 3x equals to root of 2. Just trying to rewrite things, yeah. So this one is the same thing as this one, huh? Okay. Then this here is the same thing as this one, right? With the minus sign. So that's what I did. Just interchange position. And this is what roots, no, this should be root of what? Root of 3. Because nothing changed here. This is still root of 3. Now, if you look at this, you can take 2 as a common factor. And if you take 2 as a common factor, we'll have cosine 3x sine 2x minus cosine 2x sine what? 3x equals to what? Root of 3. So now this one, we can write it as sine. Yes, this can be written as sine, right? Because, okay, one more step. This, I can write this as sine 2x cosine 3x minus cosine 2x sine 3x. Yes, so this is a combination. So this is definitely sine 2x minus what? 3x. And this is root 3. So this is just going to be 2 sine. This is going to be minus x is equals to what? Root of 3, right? And now sine is odd, so this minus can come out. So we'll have minus 2 sine of x is equals to root 3. So what is sine x? Sine x is just going to be minus root 3 over 2. All right. Okay, now this, we can say it's in the third or in the fourth quadrant. All right, so what can we do here? But what is our reference first? We can call it x star. It's just going to be what? Pi over 3, which is 60, because sine of 60 is root 3 over 2. So if we are in the third quadrant, then our x is going to be third quadrant. We just need to add, pi to this one, right? So this will be 4 pi by 3. Then we add our 2k pi. And if we're in the fourth quadrant, we just need to subtract this, our reference, from 2 pi, right? So that will be 2 pi minus pi by 3. So that will just be, I think, 5 pi plus 2k pi. Okay. So we're looking for the sum of all solution in which interval. So let's find this first. Okay, so what we can do here is, but here we know that the range we have now have a negative number, right? So because we're starting from minus pi to pi, so it means we can start with k is equals to minus 1. You can try that. If k is minus 1, what do we have from here? K is minus 1, we will have pi over 3 minus 2 pi. Minus 2 pi, right? Yes, which we can write as 6 pi over 3. And that will give us what? That will give us minus 2 pi over 3. So let's keep that first. And from here, from the numerator here, or no, from the second, case 4, we will have 5 pi over 3 minus what's 2 pi as well, which is this. And this will give us what? Minus pi over 6. So let's just keep this for that. So this is what we get when k is minus 1. All right. Now, can k be minus 2? If you try k to be minus 2, it's going to be outside, because remember, this is what we want to consider. We want to consider numbers that falls between minus pi and pi. So it means the coefficient of pi It has to be what? It has to be less than -1 or great. It has to, if it is less than -1, you can discard it. If it is greater than 1, you have to discard it as well. So let's see. But I think these two looks cool, right? All right. So let's see another one. If you try k is equals to 0, for k equals to 0, we have 4 pi by 3, which is already outside. Or we have what? 5 pi by 3. Okay. Now, so you can see that 4 pi by 3 and 5 pi by 3, they are all what? They are all greater than pi, right? So since they are all greater than pi, it means both of them have to be discarded. But let's see. Let's try another value of k. Smaller negative value of k. If k is equals to -2, remember if k is -2, I'm trying to k is -2. From here, what we'll get is that we have 4 pi over 3, then minus what? That will be 4, right? So which we can write as 12 pi over 3. And that is going to be 4 minus this is going to be -8 pi over 3. So you can see the coefficient -8 over 3. This is way outside the region, yes. And also similarly, if you take k to be -2 in these the case 4, I mean when you are in the fourth quadrant, you will have 5 pi over 3 minus what? -4, which you can write as 12 pi over what? 12 pi over 3. And this is 5 pi minus 12. This is going to give you -7 pi over what? Over 3. So, and if you have -7 pi over 3, you can see that this is going to be -2 point something. This is also way outside. So it means the only case we can consider the k is equals to -1. So I think the solution set is going to be -2 pi over 3 and also minus what? Minus pi by 6. So in here, when k is -1, this is not pi over 6, but it's minus pi over 3. So here is going to be minus pi over 3, because if k is equals to -1, if you substitute -1 here, what do you get? We'll get 5 pi over 3 minus 2 pi, right? And this is nothing but minus pi over 3. So this is because you will have 5 pi minus 6 pi, so you have this. And we can easily find the sum now, right? Okay, so now let me just explain something, because sometimes looking for the right k to use is not that easy, especially when the interval that we need is not 0 to 2 pi. So for example here, just to buttress here, you see the interval is from minus pi to pi. Now from minus pi to pi, it means we have to use this. So what we can do is we can just take what we have. This is our solution, right? So remember, we need from pi to pi. So it means our x has to be between minus pi less than x equals to x less than pi. So we have to try for the 2. So let's take the first one. It means when we are in quadrant 3, you will have less than, what is x? Take the whole answer, which is 4 pi by 3 plus 2k pi, then less than equals to pi. Is that okay? So once we have this, we can try to see what will be the possible value for k. And one way we can do that is that we can multiply, you can see this, because there is pi in everywhere. So remember this, you can write this as this one. You can take pi as common factor. So you have 4 plus 3 plus 2k and less than equals to pi. So all this pi can cancel. So you have minus 1 is less than 4 over 3 plus 2k is less than equals to 1. So it means that you can multiply both sides by 3 if you want. So this will become minus 3 less than equals to 4 plus 6k is less than equals to 3. So we just multiply through by 3. Now, if you take this here, this is minus 7 is less than 6k is less than what? 3 minus 4 minus 1. So we subtract 4 from both sides. Dividing both sides by 6, you will have minus 7 over 6 is less than k is less than minus 1 over 6. See? So this is what we will get here. Okay. So now in this case, what will be the value of k? Okay. So here, it means that we are between what? We are between minus 7 and what? Minus 7 over 6 and 1 over 6. So what will be the possible value of k in this interval? So it's like you're between minus, this is minus 7 over 6. Remember, k has to be an integer, right? So the only integer you can find here is that k has to be only what? Only minus 1. You cannot get more than this one, because minus 7 over 6 is what? Is minus 1. Minus 7 over 6 is minus 1 point something. So the only possible integer is k is minus 1. So we know that k is minus 1. So we have to just go back here and substitute k, it's minus 1. So yes, I think this is going to be k, it's minus 1. Right. So let's see. And if you substitute k is minus 1, we will get what? You'll get minus 2 pi over 3. So this is how to check for the possible values of k. Also, you can also do that again for the second one. When I say the second part, means because you have two solutions. You can also do the same for this, and you will also get k is equals to minus 1. So we have these two solutions. And if you look for the sum is just going to be minus 2 pi over 3 plus minus pi over 3. And this will give us what? Minus pi. All right. So that is it. Now let's take the last question here. It says the number of solutions of the equation, this. All right. So you have sine theta over 2 is equals to root 2 minus sine theta over 2. So what we can do here is this one. Let's see how this will work out. Now, this is sine theta over 2 minus this, and you have in which interval? In the interval 0 to 360. 0 to 360. So here we can write this as what? Sine theta over 2 plus what? Sine theta over 2 is equals to root of 2. Simple. Just take this to the other side. And this will become 2 sine theta over 2. It's equals to root 2. So sine theta over 2 is root 2 over 2. And now we have to consider the quadrant, first or what? Second quadrant. So if we are in the first quadrant, here we can get our reference theta. Our reference theta is just going to be pi over 4, which is going to be 45, which is 45 degree, right? And now if we are in the first quadrant, what is theta? But now we're going to say theta over 2 is just going to be 45 degree as well. And now you have to add 360 pi k. And this means that what is theta? Theta is just going to be 90 plus what? 720 degree k. And if we are in the second quadrant, theta over 2 is going to be what? It's going to be so 135, right? It's going to be 135 plus 360k. And this means that theta is just going to be 270 plus what? 720k. Now, since you are interested in between 0 and 200 and 360, we take k to be 0. If k is 0, we will have theta to be 90 degree and what? 270 degree. And if you take k to be 1, you will have, okay? So I think we have only 2, and that is when theta is equals to 0. Because if we take k to be 1, it's going to be outside the interval. So solution sets only 90 and 270. So the answer is what? Is 2. All right, thank you for watching. This is the end of the video for the old exams. So do not forget to subscribe if you are yet to do that, and also share with your friends. Thank you for watching.